Welcome to solving technical coding interview questions. Today we shall be looking at this question. It says remove element. Given an array norms and a value, remove all instances of that value in place and return the new line. We are not to allocate extra space for another array. You must do this by modifying the input array in place with constant extra memory. The order of element can be changed. It doesn't matter what you leave beyond the new line. Excuse me. Given 3, 2, 2, 3, but 3, so your function should return length 2 with the first two elements of norms being 2. So we're given a value, excuse me, and we have to remove that value from the array. Then whatever is left will return. Here we're given this value 2, we have to remove that value from the array, so 0, 1, 3, 0, 4 is left. Okay, so how do we go about this? Don't forget our normal method, the umpire method. So the first is U. So that is, we try to understand the question. Now, in trying to understand the question, it's pretty clear. We may need to ask our interviewers some edge cases. Is it possible for the norms to be empty? What should we do if the value is not in the numbers? So definitely we should just return the length of the array if the value is not there. For instance, if value is 7 in this first case, in this first example, we'll just return 4. Okay, any other? Well, we may want to know whether it will be sorted. That can help our algorithm. If the array will be sorted, that's basically what I can come up with now as the clarifying questions. So the next in is the M, which is the match phase. We try to match it with existing problems that we have done in time past. So we're dealing with arrays here, and we need to be removing elements from arrays, or we can just count each time we see there are two ways we can go about it. Is either we remove the element from the array, then we return the length, or we count the number of times the value is in the array, then we return the size minus the length. So whichever way, we come up with the same thing. So the next phase is the P, which is the plan phase, the pseudocode phase. So this pseudocode will just be, we iterate through. So this will be our pseudocode. So we just iterate. So the first thing is we iterate through we can iterate through the array. So iterate through the array. All right. So we iterate through. All right, and well. All right. So we iterate through our array, and once we're done with that, let me do that properly. Okay. So let's do that properly. So we iterate through. All right. So the next thing we try to do is we get like a counter to increment, to count the number of occurrence of the value. So counter. So as we iterate, we continue to check. We get a counter to increment that. By the time we get to the end of the array, then we just return the size of the array minus the counter. So that's pretty clear now. So we can go to the implement stage now. So let's go to implement. So let's go to the implement now. Okay. So to implement that, we can just say, oh, what happened there? Yeah. So we say for, let's have a counter that is equals to 0. Then we say for num in nums. Then we check if the current number is equals the val. Then we increment our counter to be equals to plus equals 1. At the end, we return the length of nums from the value of the counter. So this should work. So let's now do the review. Let's review our code based on what we have done. So we'll review our code now and try to see how well it works. So and we have 3, 2, 2. So we copy this too. Okay. Alright. So this is our code. Yeah. Hopefully we can see it very well. And this is the number. Okay. Good. So let's do a walkthrough now. We're in the review stage now. So we have our nums. Our counter is 0 at this point. So our first num, what's our value? Our value is 3. So our val is 3. So we can just write that. So our val is equals to 3. Okay. So the first number is 3. If num equals val, so we increment our counter, so our counter becomes 1 here. Then we move to the next. We're done with 3. The next is 2. Is 2 equals val? No. So we don't do anything. so we'll move to the next. Is 2 equals but no, we don't do anything. So we'll move to the next. Is 3 equals but yes, so we increment our counter. So our counter changes from 1, it becomes 2. Then we get to the end, and that's all. So we return the length of the array, which is 4, and minus 2. So this returns 2. And that is exactly what we expect. So that's exactly what we expect here. That will give us 2. So let's try with this also and see what it gives us. Good. All right. So here, let's do some cleanup quickly. So clean up this, and this. So our val here is 2. So our val is 2. So here we get the counter to be 0. And our first number is 0. Is 0 equals to 2? No, so we don't do anything. Then we move to 1. Is 1 equals to 2? No, we don't do anything. Then we move to 2. Is 2 equals to 2? Yes, so our counter becomes 1. So we're done with this. We move to the next 2. Is 2 equals to 2? Yes, so our counter becomes 2. So our counter becomes 2. Yeah. So we're done with this. Then 3 is 3 equals to bar? No, we're done. Then 0 equals to bar? No. 4 equals to bar? No. Is 2 equals to bar? Yes. So we increment our counter. So our counter becomes 3. So this is 3. So this is 3. Then we return the length. The original length is, this is 3 is 8. So that will be 8 minus 2. This is 8 minus 2. So this gives us 6. So we return 6. So that is the review stage. The last stage is the evaluate. So the last stage is the evaluate stage, which is the E. So what do we do in evaluate? The time complexity. So the time complexity will be linear because we are just iterating through once. So it will be linear. So that will be big O of n. That will be our time complexity. And then our space complexity, the space complexity will be constant. That will be big O of 1. The reason is we are not allocating, we are not continuously allocating extra space. We are using constant space, which is just the counter. Okay, we're done now. So let's look into our code and see whether it runs. Wow. We didn't run. Oh, we have to remove all the instances. We're supposed to remove those instances. got something wrong there. So we're to remove all the instances, not just in place, and we return the new length. Oh, okay. So let's see how we can modify that to return all the remove all the instances. Okay, so this is where we're going to remove those instances. So instead of just having a counter, we will just remove the instance. So if the num equals val, so what we can do now is we will need to change this to an index range length of nums. So that's why we need to look at our question specification very well before we implement. So length of nums. So if nums of I is equals to val, then we will need to remove that particular instance. But so when we need to do anything like this, it's better for us to use the while loop, because we'll be altering the size of the array. So the while loop is easier to manage. Sorry, we didn't look at the question very well. So if nums of I equals val, so what we do is we delete that nums of I. But because we have deleted that, something will have happened to our size. Our size will have reduced, so we need to reduce our size. And so the tricky part is now for us to now try to see, do we need to, so here we just return the size at the end of it. The tricky part is the when we are not deleting. So if we delete that I, should we increment our I, or should we leave our I as it is? We know the else part is that if it is not equal, we just increment our I. That's for sure until we get to the end. But here we need to know, should we increment our I or not? Because if we remove the element, if we increment our I, what does it give us? So the best way for us to know that is for us to run it through an example, and that will show whether we should increment our I. So we need to do this again for the next one. So let's delete this, and so let's paste this, and let's get rid of all the other ones. So we're doing it again. So get rid of all this. Get rid of all this. So let's go back here and use this to trace. So our value here is 3. So our value is 3. So let's now see, we pick the first element, which is 3. Then our length is 4. Our I is 0. And we see that 0 is less than 4. 0 is less than 4. That's true. Then we check if num sub 0, which is 3, is equals to our val, which is 3. Yet it is equal. Then we delete it. So we delete num sub I. So let me rewrite it here so we can see our array very well. 3, 2, 2, 3. That's our array. So the indices are 0, 1, 2, 3. So this is the first element, 3 is equals to the val 3. Then we delete that first element. That is num sub I is 0. So let's delete that. Now by deleting this, a lot of things have changed. Our indices too have changed. So the indices that was 1 before, they now become 0, 1, 2. Alright. So we delete the first index, we reduce the size. Yeah, the size is now 3. So we did not increment I. Okay. Then we go back. And we check high is still 0 because we didn't increment high. Is num sub high. So our size has changed from 4. Our size has become 3. So it's num sub I equals val, that is 2, is equals to 3. No. Then we increment our I. So our I becomes 1. Then we say again, 1 is it less than 3? Because our I is 1 now. So get to 1. We check if 1 is less than 3. Yes. So it's num sub 1 equals val. What's our val? 3? No. So we increment our high. Our high becomes 2. So our I becomes 2. Okay. So this becomes 2 here. And this is 2 less than 3. Okay. So our num sub 2 is 3. Is 3 equals val? Yes. So we delete num sub 2. So this is the num sub 2. We delete this. Okay. We delete our num sub 2. This goes. Yeah, that goes. And our size becomes 2. So our size changes to 2 here. Alright. So our size has changed to 2. So by the time we come back to our iteration, then we say our high is 2, our size is now 2. Is 2 less than 2? No. Then we return the size, which is 2. return the size we choose. Okay, so this should be correct. Our complexity is still big O of n. Time complexity is big O of n because we are iterating through the element 1. Our space complexity is still constant. That is big O of 1 because we're using a constant space. So let's run it now and see what we have. Great. Accepted. Wow, good. So thank you very much for listening. Hopefully you benefited from this, and you've also learned from our initial mistakes of missing out the question specification of removing all the instances, and those things are very important, and that's the essence of such tutorials like this, for us to be able to see how we can get it wrong in an interview process. Do give us a thumbs up, and please subscribe for future tutorials. Thank you, and see you in the next one.